Wednesday a little bit. Now, for those of you who have any challenges with doing these diagrams, the rules method test might come in handy. And I'll just write this down here. There are several rules that are followed by all valid categorical syllogisms. If any of these rules is broken, what can you conclude?
Invalid.
It's invalid. All you need to do is recognize one rule broken and you can know ahead of time that it's invalid. Now at some point you may be asked to use this rules method on a quiz or examination. Hint, hint. It's actually very easy to use once you're used to it. Now, the first rule I'm going to talk about pertains to negations. Now, when I'm talking about negations, what two kinds of statements are negations? E's and O's. A's and I's are affirmations, E's and O's are negations. Now this is the rule pertaining to negations. The same number of negations found in the conclusion must be the same number of negations found in the premises. The same number of negations found in the conclusion must be the same number of negations found in the premises. Now this of course sounds very fancy, but applying it, it's not fancy at all. What is the maximum number of negations that you could get in a conclusion? One. It's only one premise, so it's either going to be an affirmation or it's going to be a negation. So if my conclusion is a negation, one and only one of the premises must also be a negation. One and only one. Now, based upon this rule, we can rule out a whole lot of moods as automatically what?
Invalid.
Automatically invalid. Examples?
E, O, O.
Suppose both of my premises are E's. I can rule that out as being invalid. Why? Because it's got two negations. And we said that the same number of negations found in the conclusion must be the same number found in the premises. So EE is automatically invalid. If my premises are both O's, it's automatically invalid. And I don't have to look any further. All of these are automatically invalid. You can know that right off the bat. Take a guess what else you can conclude based upon this rule. If my conclusion is a negation and both of my premises are what? Affirmations, I can know that it will be invalid. Give you an example. If you see a syllogism being proposed that is an AAE, automatically invalid because you've got one negation in the conclusion and you've got zero in the premises. Suppose you saw an EII. Will that be valid or invalid?
Invalid.
invalid because we got 0 negations here, we've got 1 in the premises. Give me another example. That one will also be invalid because you got 0 negations in the conclusion, you got 1 in the premises. Now, by extension, if your conclusion is an affirmation, both of your premises had better be what? Yeah, they better be affirmations too. This rule right here basically rules out the vast majority of syllogisms ahead of time as invalid. Now, the second rule, folks, can be broken up into 2 parts. These 2 rules pertain to a concept called distribution. Guess what? We have not spoken of distribution yet. Take a guess where else distribution is not discussed. It is not discussed in your textbook. However, it is a very important concept for understanding the mechanics of syllogisms. Now, roughly speaking, this is what distribution means. A term is distributed if all members of that term are being referred to. A term is a distributed term if all members of that term are being referred to. Well, which terms are distributed in which kinds of statements? Well, I'll go through a chart for you. I don't have time to explain the mechanics of why because of how long we have today, but I can at least get you started on it. A statements will distribute the subject only. E statements will distribute both subject and predicate. I statements distribute no terms. And then finally, O statements distribute the predicate only. Now here are the 2 rules. The middle term must distribute in one of the premises. Or to put it another way, the middle term's got to distribute. If it doesn't distribute in either of the premises, you can automatically rule it out as invalid. Now, the second of these rules reads, if a term is distributed in the conclusion, then it must distribute in its corresponding premise. If a term is distributed in the conclusion, it must distribute in its corresponding premise. Now, since we have enough time to put this to work, let's do so. Suppose I have a syllogism that is, let's just do this one. This is one we've seen before. Suppose somebody throws us an AII2 syllogism. We can write it out just to make it easier to test the method on. If I'm writing out the AII2 syllogism, what comes next? If it's 2, my predicates have got to be the conclusion. There you go. That's what an AII2 syllogism would look like. Now, to go through the rules method, and we can just write it down this way. We've got the negation rule, and we've got the 2 distribution rules. Does this one pass the negation rule test? Yes. We've got 0 negations in the conclusion, and we've got 0 negations as the sum total of the premises. So it passes the negation rule. Does this one distribute the middle term? The chart's right here. Does this one distribute the middle term? Good. It does not. The middle term does not distribute in either of the premises because it's the predicate of A statements. A statements only distribute subjects. And it's the predicate of an I statement. I statements don't distribute any terms at all. So this one is invalid. And the technical name for the fallacy it commits is what we call an it's called the fallacy of an illicit middle term. And if you don't want to call it an illicit middle term, undistributed middle term is perfectly fine too. Now folks, you already knew that this one was invalid because we demonstrated it how? We did a diagram of it previously. The beauty of the rules method is it tells you exactly what deductive formal fallacy is committed. When you use the diagram, you can demonstrate whether it's valid or not pretty easily. But you don't necessarily get to the source of why it's invalid. This one explains invalid, undistributed middle term. Guess what we're going to do now? Another one! Yes, thank you! Can someone give me a mood and a figure? And we'll do it. Any takers? A, E, O. And what figure would you like? AEO4. Now folks, I can tell you ahead of time that this one is invalid. Let's find out why. All P or Q, and because it's figure 4, my middle term's going to be here. get out of the way. There we go. A, E, O, and that's fourth figure. You know that just from memorizing the figures. Now, let's go through the rules. And simply put, I can enumerate them this way. Negation rule here, distribution rules here. We'll have middle term and conclusion. Does this one pass the negation test? This one does pass the negation test. Why? Because my conclusion is an O, which is a negation, and only one of my premises is a what? Is a negation. So this one passes the negation test. By process of elimination, there's going to be some kind of a distribution problem. Does my middle term distribute? The answer is yes. Distributes as a what? As the subject of an E statement. The middle term distributes. Does this one distribute the middle term? It does not, because A statements don't distribute predicates. This one passes this test. Guess what test it's not going to pass? The conclusion one. If a term is a distributed term in the conclusion, wait a minute, did I do something wrong here? I feel like I did something wrong here. Oh, this is an interesting one I'm going to have to explain to you. Because check this one out. Here is a term that is indeed distributed here. But guess what? It's actually distributed here too. This one's an interesting one I have to explain to you. Because even though this one looks like it does what? Passes everything. There is another problem with this one. These two premises are what?
Opposites.
Not quite. These two are universals. Guess what the conclusion is? It's a particular. This one's a particular. And this is something a diagram will show. Take a guess what this would require in a diagram to be valid. An X. For an A or for an I or an O statement to be valid, validly deduced, there's got to be an X on the diagram. Take a guess what these things won't do. They won't give you an X. Now, I'm glad you gave this example because I have to point out a peculiarity that will not show up on a test. And this kind of goes into some technical detail. These statements, universals. Universal statements can technically be true even if we're talking about a class that has no actual members. I could say all round squares are red. Now you'll notice there's no such thing as what? Round squares, but I could perhaps conceptually construct them. That's kind of perhaps a stupid example. I'll give you a better one. All unicorns are horse-like creatures with a single horn in the middle of the forehead. That is a true A statement, even though what? As far as I know, there are no such things as unicorns. Universal statements can be true even if we're talking about classes of things that have no actual members, merely conceptual members. I and O statements, in order to be true, they have to have what? Actual members. And there's a technical word for this. I and O statements have what logicians call existential import. By the way, it has nothing to do with the philosophy called existentialism. So don't, if you've talked about that, do not, in another class, don't confuse the two. Existential import really just means there are indeed actual members. I and O statements, in order to be true, have to have at least one actual member. A's and E's can be conceptually true, even if there are no actual members. Yes, sir?
So your premises are both particulars, you can't have a universal conclusion?
Well, he's right. If both of your premises are particulars, you cannot draw a universal conclusion. Now, that is not a rule, but guess what? It is derivable from those rules. And let me kind of illustrate. No, we won't kind of, we will illustrate. Let's say our syllogism is an IIA1. That would read something like this. Some P are Q, some R are P, therefore all R are Q. Take a guess what rule this one breaks.
Negotiation?
This one will have an undistributed middle term. Your middle term is the subject of an I and a predicate of an I, but I statements don't do what? They don't distribute anything. Now, you'll notice it breaks one of the rules on our list here. But the simpler way you could put it without going through the rules is you cannot derive a universal premise from two particulars. And folks, that's probably common sense to you already. That's probably already a sort of common sense that you've already inferred, that you can't derive a universal from a particular, or from particulars. From particulars, you can only what? Derive other particulars, if you can derive anything at all. Now, I want to give you one more punchline. If both of your premises are particulars, take a guess what you can also conclude. The syllogism will also be invalid, because one of the distribution rules will necessarily be broken. But yeah, if both of your premises are particulars, it will be invalid too. So in other words, if your two premises are any of those moves, you can also throw it out. Castle.
It's 38, can I go?
Oh, yeah.
That's not good. That's not fast.
Oh, yeah. Have a good one, folks.